talk to you all a little bit today about Teaching Haskell. And before I get started, I just wanted to say that we have some books to give away, and we're going to have some opportunities for participation. So I hope those of you who are really interested in getting a copy of Category Theory for Programmers will chime in and take hold of those opportunities and maybe get one of these wonderful texts. So I wanted to talk about Teaching Haskell because there's a pattern that I've noticed in our industry. It's a pattern where, you know, we're all learners, we're all thinkers, we're all people that are constantly having to do new things and solve new problems. And there's a very kind of bimodal distribution of adoption. When we think about these technologies, you know, some things really take off and they gain a lot of prominence, and other things, you know, they don't go real far. You have the advocates and even the zealots that are really pushing them. But why is it? Why is it that, you know, you can have a language like Haskell that is, you know, 20 years old, is very well respected, you have a lot of people talking about it, a lot of people interested in it, but it never really goes anywhere, and like every JavaScript framework, like 3 months later, you got like 2 conferences. So it's clearly not just about the learning. So what I'm hoping to do today is talk to you all about a few things. One is about Haskell, because I like talking about Haskell, and I think it's really interesting. But more importantly, I want to talk about this broader process of technologies and adoption, and especially the notion of taking some technology that you're passionate about and bringing it to a team or a group of people. And then finally, all of that we're talking about when we're talking about teaching people is also what we need to turn inward when we want to learn. So hopefully we can learn a little bit about Haskell, a little bit about teaching, and a little bit about learning all at the same time. So the first thing when we're talking about teaching is we need to understand who we're teaching. We need to relate to people and understand who we're talking to. The way I like to think about this is, you know, I like to think about teams, because I'm usually, when I'm bringing a new technology to somebody, I'm bringing it to the people that I'm working with. I'm saying, hey, I think this is something that we can adopt, and how can we do that? And I like to think about the teams that I've worked on, and you know, they often fall into different sorts of buckets. And not everybody's going to group these the same way as I have, but I think the exercise of understanding the types of people that we're working with and what their motivations are is very helpful. So let's go through some of the teams that I've worked with. So we have the listers, right? And this is what I'm calling the team of people that, you know, these are language people, and they might be using Clojure, maybe using Scala, maybe using Ruby, but these are people that usually care a lot about their craft and what they're doing. And you'll often have 1 or 2 people on that team who have tried to learn Haskell before. And this is really, you're going to have a hard time selling these people on this technology, because they've been there, they've done that, and they already think it's a bad idea. So the challenge that you're going to have when you're dealing with a team like this is, how can you take your positive experience and address that to this group of people while respecting the experience that they've already had? Because if you tell them, no, you're wrong, then they're going to shut down. They're not going to hear what you have to say. So realize that their experiences are real and acknowledge those, and then bring your own experience to the table and relate that to them. This one might be familiar to some of the people here. 1 or 2 of you should have heard this word before. So the Polyglot team, this is the easiest team in the world to sell to you, because it's basically like the Lispers, except nobody's already failed to learn Haskell, so you don't have a whole bunch of baggage that you're coming in and trying to overcome. So when you have this group of people that are excited, they want to learn, they want to do the new thing, this is really like, this is your easy mode. You can bring the idea in, but you still have to follow the process of introduction and education when you're doing this. You can't just say, okay, well, we're going to use Haskell, and that's the end of it. It's never quite that easy. Another group that we have are what I like to call the consultants. And these are teams that are often very conservative in the technology that they're using. You know, it's maybe a team that's using Java, maybe some JavaScript if they have a front-end component, but you know, not doing very interesting stuff. And at least on the language side. And you might think like, oh, okay, well this is the hardest sell that I can encounter because these people are using boring technology. You know, but the thing to remember is people that are in this situation, they're not necessarily doing it because they're stupid. They're not doing it because they can't learn something else. Teams like this are often very thoughtful and considerate about the tools that they're choosing to use, and they invest a large amount of time to make sure that they have everything that they need to be productive with those tools. So for a team like this, you want to come to them and you want to demonstrate the benefits very clearly. You want to talk to the costs because people on teams like that are often very cost averse. So you want to be able to speak and say, you know, we can gain these benefits. We can gain, you know, a lower rate of errors, faster refactoring time with our type system over some other language. And the nice thing about a team like this is because they're not using a lot of technologies, it gives you more time to really invest in teaching and helping people understand the ones that they are using. If I think to the team that I'm on right now, I think we have 7 programming languages in our code base. That's not a lot of time for people to really spin up on one. But if you have 2 languages and you introduce a 3rd, that's a much bigger percentage of individual mental overhead that you can dedicate to actually learning that language. And the final team, the agents of chaos. Deceptive, because on these teams where nobody's talking to anyone and everyone's just doing their own thing, you might think you have a golden opportunity to ask for forgiveness later rather than permission up front. And I've done this. It doesn't work out as well as you might think. Because the problem that you're going to run into here is on teams where people aren't communicating well, teaching people is going to be very hard. Onboarding people is going to be very hard. People want to go off and they want to do their own thing, they want to be left alone, they don't want your help. And unless you're on a team of people that already know Haskell, they're going to just get really upset that you've now introduced this language that they don't know how to work with. They don't want you to help them learn it. You know, and so it becomes this situation where you've alienated people. You're being seen as having gone rogue because now you introduce this thing into an environment and nobody can work with it and nobody wants to work with you to learn it. So these are the sorts of ways that I like to conceptualize teams and the sorts of groups that I work with. But what I really like to do is get somebody out in the audience to talk to me a little bit about their team and how they can represent their team as an archetype, and you know what are the difficulties and the benefits of trying to sell a new technology to your team.
My boss is like every new language we introduce is another dimension that we have to consider when finding new people, and so got to make a pretty compelling case that anything we introduce is going to increase our productivity over the opportunity cost of not being able to find people for it.
All right. Well, why don't you grab one of those hooks there? And you make a really good point, which is that a lot of the process of introducing a new technology to the team is not upfront about education. It's about sales and social engineering and understanding where people are at and meeting them there and getting them to agree with you that this idea is a good one. And the first challenge that you're going to overcome, especially with a language like Haskell or any programming language really when you're introducing it into a team, is you're going to be painted as a zealot. We've all seen it, right? You come into a team, you know, the team's using some language, doesn't matter really what it is, Python, Shop, C++, Java, Scala, a Haskell team, whatever, and you say, hey, let's use this other language. All of a sudden, you are not to be trusted because you are You are the Haskell person. And now, not only are you responsible for, making sure that people hear out your ideas, but you have to be defensive in everything you do, because not just your suggestion of this language, but every suggestion that you make is now going to be questioned. Your motives are suspect because you've introduced this obstacle, this enemy that you've dragged into the four walls of the team. And so people aren't going to trust you, and they're going to not like you. This is going to happen more or less depending on how good your team is. But there's always just that little bit of being the outsider, because you say, hey, I think we should do this different thing. And people don't know how to value that. So they see it as being kind of risky. And then that sort of attaches itself to you. And what I have found the best strategy for dealing with this is to just be very humble and kind of self-effacing and kind of joke with people and make yourself seem less intimidating, make the process of adopting the technology seem less daunting. Because nobody likes a pushy salesperson. And in our industry, we always have people trying to sell us on an idea, sell us on a concept, sell us on a process, a language, an API. And so we've hardened ourselves to that, and softening that with just friendliness and humor can go a long way toward opening people up to your ideas.
So I like to think about it as pulling people in by showing so much interest that they become curious. Mm-hmm. Like, wow, why is she this interested? What's behind that?
Right.
And sort of, pull them in instead of push them away.
And, another thing that does work is heroics, right? Like, every team has something that's going wrong. Like, every team that I've ever been on, there's something that is broken or just incorrect, or that everybody thinks is a good idea, but nobody's had time to get around to doing it. And this is an opportunity to demonstrate the value of what you're trying to teach without being pushy, because now you're delivering value first. So you want to look for opportunities. You want to look and see, like, what are some things that people really want? And they usually need to be something that's standalone, right? You don't want to push some new feature into your main code base that is going to introduce a new language, but a tool, like, I want something that will help me manage these servers, or I want a quick report on what all the types of bugs that we've had, and I want a tool for that. And these are your opportunities to show the value of your technology or your language. But you've got to do it right. You can't come across like you're going rogue, like you're saying, you know what, I don't care what you guys like, I don't care what the standards of the team are. You got to really put the features and the benefits of the language first. So this goes back to being self-effacing and humble. You want to be almost apologetic, right? Like, you know what, I'm sorry, I know we're a Ruby shop, I know we're a Python shop, but it was just, we really needed this tool, and it was just so much faster for me to write it in Haskell, because it's so much easier for me to refactor, and I don't run into so many bugs. And I really love if somebody can look over this with me, because I don't want to be the only person that knows it. So now you're pulling people in. Like Craig said, you're creating an opportunity for people to come in and join you and become an ally in this process rather than an adversary. And you're also demonstrating and providing a path to teaching by having something small and standalone that people can look at. And that point of finding an ally, that's critical, because there is always going to be that slight adversarial relationship that's introduced when you're trying to sell somebody on a concept or an idea. So you come in, you play the hero, you deliver something of value, you ask humbly for somebody to help you de-silo and to help you by learning this piece of technology that you've introduced. And you're the output when it comes to this technology. You're the person that's coming in and trying to dictate from on high, I think we should use this. And so you bring your ally in, somebody that's interested, and you mentor them, you help them, and you give them success. You give them an opportunity to see the benefits through your eyes and through their eyes through shared experience. And then you let that person go and advocate for you. Because now, that person, they're not the adversary. They're part of the in-group. And so their words are going to carry far more weight when they're advocating and just restating the position that you've been holding from the time that you said, like, hey, I think we should look at this. When you start getting a few people that are showing a little bit of interest on the team, you really need to focus on making the team successful as quickly as possible. A good way of doing this that I found is having some missing features. That piece of code that you delivered, that application that everybody really agreed that you needed, that was really helpful, leave a feature out. And then create a bug in whatever bug tracker you have. And be very detailed. Like, go to this source file, consider using this function to write something that looks kind of like this. And what you're going to do is you're going to give people that immediate positive feeling, like, oh, I can do this. This wasn't so hard. Look at what I accomplished. I delivered this value. Now my name's on this feature. And you start getting people to want to buy into it. One of the things that I found with Haskell in particular is when you're wanting to set up people for success, you really need to be mindful about how you structure your code. Because there's a lot of ways that we might write idiomatic Haskell that puts a lot of the difficulty sort of evenly distributed throughout the application, right? And when I say difficulty, I mean the things that people are going to have a hard time conceptualizing. So what I like to do for projects like this is I don't really write very idiomatic code. I write code that's fairly verbose. And I also structure it, rather than structuring it as per data flow or as per the domain that I'm working in, I try to layer it based on the difficulty of understanding the abstraction. And so even if it's more code, even if it's more work, even if it looks a little weird to an experienced developer, the upfront experience of a new person coming in is, oh, look at this. This looks just like any other scripting language that I've seen. I mean, I don't know what that do word is there, but this looks perfectly normal. And you give them a very easy gradient into more advanced concepts. And of course, you want to make sure that the first bugs that you submit really only need them to be working in that higher level, very easy to deal with part of the code base. And then as time goes on, as people get more comfortable, you can start pushing them a little bit further down into some of the more burdensome abstractions. The last bit when you're trying to sell a technology to a team is really just knowing when to shut up. I said when to speak because that sounds nicer, but it's really about knowing when to shut up. Winning hearts and minds, that's what you're trying to do. Before you can teach people, you need them to trust you, and you need them to like the idea. And it just doesn't happen overnight. No matter what you're trying to sell, it's going to take people some time to come around. So you want to push a little, but you want to focus on a cadence that works for your team. Introduce something, introduce your new feature, write your bug, and then wait a month or 2 months or a quarter before you bring it up again. You want to be very, very intentional about leaving a lot of space for people to absorb and get accustomed to the last thing before you introduce the new thing. And then, just disarm the accusations of zealotry with your behavior. Carry yourself well. This comes back to the cadence, right? Hey, I think we should use Haskell for this project. And then, well, even if Haskell's a great solution for the next 3 projects, I'm not going to recommend it, not right away. Because that's going to make people seem like they have an agenda. Regardless of whether it's the best solution or not, I want people to feel comfortable, and I don't want them to assign an agenda to me. So I'm going to step back and I can say, oh, you know what, no, we should use Python for this thing. Python's a great fit for this. And then I can come back in later, look for a new opportunity to introduce Haskell again to the team. So before we move on to the next section, I'd like to get a little bit of feedback from people. Why do you think Haskell is hard?
Compiler errors. Yes.
Yeah.
It's abstract. You get to a certain point where it's like, the new functional concept that other functional languages don't have.
I guess the one thing is, you're not going to have a mentor that knows it if it's, already knows the catch-22 of popularity.
Yeah.
It's more different than most things I've encountered.
All right. Yeah.
Jonathan, the update done.
Sorry.
Ask him, Jonathan.
Yeah. All right. You got a book for that one.
With more jargon.
Hopefully it'll explain it.
Thank you. So I want to talk a little bit about how people learn Haskell. And you can extrapolate this out to, I think, most technologies. But Haskell's a particularly good example of this. You know, the first thing that happens is people are like on Hacker News, right? And they're flame warring and, you know, talking about how crappy Electron is or whatever. And then, you know, they see yet another reference to Haskell. And at some point something clicks and people finally say like, you know what, I should go read about that. I should try to learn this language. And so they'll go out and they'll pick up a book, maybe learn you a Haskell from first principles, maybe go out to the wiki and they'll find some introductory articles. And they're going to sit down and they're going to write a couple of things, quick sort, Fibonacci series, the sort of things that are really great examples of the Haskell syntax, making things very easy. So they're going to write some code like we have over here on the side of the screen, and you don't have to really understand what that does. Just, you know, some great examples of here's Haskell, and this is good. And they're feeling really good, and then they hit the trials. And the trials are what I'm calling these key points where people tend to stop trying to learn Haskell. And the very first one is printing something to the screen. Usually people can do it, and then they go, why did that work? And then they run away screaming very quickly. Because they see do notation, and they're like, why the hell are there two different ways to assign variables? This makes no sense. And if they get past that, they're gonna hear about terms like monads and functors, and they're gonna kind of maybe get it, and then they're gonna kind of maybe not get it, and then they're gonna have a hard time, or they're gonna run into higher kinds of types, or type classes, or monad transformers, or they get through all of these sort of key learning obstacles only to find out that they've learned a lot of things and they have no idea how to put it together into a functional program. Pun unintended, but appreciated. But finally after struggling with all of this, victory, right? They get it. It finally starts to make sense. They write a couple of applications, they write a monad tutorial, and it finally starts to click. And when that happens, the other things that happen here that are really important is the pain fades. They forget all of those trials. They forget all of the trouble that they had trying to struggle through understanding what that type signature means. And all of that work that they put in, all of a sudden it just seems self-evident. You know, of course that's what it is. It's so obvious. It's right here. Just look at the type signature. Clearly you should know exactly what this is doing. And with that is the zeal to apply new skills. I almost use the XKCD regex comment here. You know, you learn, you got a new hammer and you go out looking for nails, and everything is great and painless except for these other people. And this is most of the people that start trying to learn Haskell. They come away defeated. They hit one of those obstacles and they never went any further. And so instead of feeling like all of this is so obvious, forgetting all of that pain, they hold into it and they just sit there and they think about this language, and nobody wants to feel stupid, right? Nobody wants to feel like, oh, I wasn't smart enough, I wasn't good enough to understand this. So they sit there and they think, well, I don't want to use that language anyway. It's impractical. It's just a novelty. It's not good for getting any real work done. And you know, they're going to think, oh, well, all of those people that are saying that this is so self-evident, all of those people on our last slide, they're just arrogant, snobby jerks and type theoreticians, and I don't really care what they have to say. And what they're really saying is, I'm not going to try again because I'm afraid to fail. I don't want to feel bad, and failure is a bad feeling, so I have learned to avoid this language in the future. But why do they? Like we said at the beginning of this talk, people pick up new JavaScript frameworks all the time, new testing frameworks, new non-functional languages. You know, we're constantly learning in our industry, but people fail with Haskell. Why is that? Well, they give up. when it really comes down to it, there's nothing about Haskell that is so cognitively demanding that any software developer who is motivated to do so can't learn it. Except they hit points where they give up. They either don't believe in themselves or they don't know how to proceed. They don't know where to proceed. You know, people that get through the first, call it maybe half, 2/3 of the common books that are out there, they start to get a feeling for what I'll call kind of the base of the language. But then there's this open world, right? It opens up and there are all these things that you can learn. You can learn about type families or type level programming or monad transformers or arrows. But people aren't really given a good sense of where they should go next. They don't really know what's going to be useful to them. Haskell as a language is used in industry. It's used by researchers. There are a lot of different people with their own motivations doing different things. And it can be very hard for somebody that's not in that ecosystem to understand what's useful for my problem domain. The other really common failure scenario that I see with experienced developers is the failure of depth-first search when they're trying to learn. Because what happens is, as experienced developers, we start to develop heuristics. We get to the point where we don't really like not understanding our abstractions, because who here has never been bitten by misunderstanding an abstraction that you're using? I see one hand go up and I don't believe you.
Sorry.
So we're trained, right? We're trained to avoid that pain by trying to understand our abstractions. And so we go depth first. We don't understand things, so we say, okay, I'm reading this, and well, this says a monad is a monoid and a category of endofunctor. Well, what the hell does that mean? Okay, I guess I'll start. A monoid is a semigroup with an identity elements. Okay, well, a semigroup is an associative magma. What the hell is a magma? A magma is a closed set with a binary operator. I don't even know what I was doing. There's yak here everywhere. And I have no idea what I was even, why I even went down this path, right? So they blow their stack, right? Like you just lose context about what you were doing because you don't have context. You don't know what's important. You have trouble understanding the difference between a concept that is really some great universal mathematical truth and some shit that somebody just wrote because it was convenient and then they put some mathematical language on top of it. You have no way of telling the difference, and you end up going just down this long, deep rabbit hole. And the other problem is you don't have the words. You don't have the vocabulary to understand the explanations that you're being given. If you think about somebody that sits down to write a program in Haskell, they're coming from, let's say, Go, right? They're going to have to learn Haskell-specific jargon, and then they're going to have to learn functional programming jargon. And they're going to have to learn programming language theory jargon, category theory jargon, and the jargon of the domain that they're working in. They're probably going to have to learn at least 5 or 6 new curse words to express themselves because of all of this jargon that they're trying to learn, right? So you end up in a situation where people can't think and understand clearly the information that's being presented to them because they don't have an anchor, they don't have context for the information, they don't have the words to understand the information that's being presented, and they're already so deep in a stack of concepts that they can barely even see the sunlight. And in the Haskell world, we're not ignorant to this, right? Like people know this is a problem, and they solve it in exactly the wrong way. And I call this the burrito bubble, because one of the jokes that you see floating around sort of the functional programming universe is, you know, a monad is like a burrito. And, you know, people think, well, that's kind of weird. Why would you ever try to explain a monad like a burrito? And the problem is because some very well-intentioned person sat down and said, you know what? People don't get this because they don't have the words to express these ideas. So what I will do is I will express these ideas in words that a person can understand. And so that way, we're speaking the same language, and they can come up to speed, and they can understand what I'm doing. And this is, of course, not helpful at all, because the words that they're using, the abstractions that they're presenting, are going to lead people off in exactly the wrong direction. But finally, if you make it through that, you make it through the vocabulary, you make it through the depth-first search problem, you're still going to have this last mile challenge, because there are so few people in the industry that are using Haskell that you learn the language, and then who are you going to work with? You don't have the opportunity to go work with a set of colleagues that already know this language, and you're not going to have maybe the time to write a large-scale project on your own, and you never really know a language until you work on something big with it. And because of this lack of really common prevalence of the language, people kind of develop their own idioms and their own styles. So you don't really even have one universal right way of writing things that somebody can blog about, right? Because every team's kind of doing their own thing. So I have another exercise here. We're going to look at this phrase. A profunctor, or more accurately, an endo-profunctor in the category of past, is a bifunctor that is covariant in one of its arguments and contravariant in the other. So what's wrong with this? Jargon. What else is wrong with this?
Typo inaccurate.
This doesn't help Haskell, someone who doesn't know Haskell.
Yeah, this is absolutely useless to anybody that doesn't already know what a profunctor is. So if we look through this, we can see that we have all of our problems just heaped into one example that I'm sure some Haskeller somewhere in the world has written in a blog post. So we have our language problem, right? Because just pick out the vocabulary words that people probably don't understand. Profunctor, endo-profunctor. Category is one of those misleading ones because people use it in very specific ways. So we got our jargon. Hask, what the hell is Hask? Probably has something to do with Haskell, but people don't really know. If you go searching for that, all you're going to do is find a whole bunch of flame wars over whether Hask is a category or not, and it's not going to explain what either of those actually mean. Covariant, contravariant, arguments that might tell you that this is something that has arguments, and it's probably going to lead you in the wrong direction, right? So we run into these situations where all of the ideas, all of the things that make it difficult for somebody to learn the language come so naturally to people who have spent 5, 6, 10 years in this world and have enough context. And so we have this huge problem with communication. And this is going to happen with not just Haskell, but with any technology that somebody's trying to learn. We have our own jargon. I mean, I think about, the jargon that's around really like the Java ecosystem or the JavaScript ecosystem. I think there are like 17 different things that are maybe kind of sort of like transpilers and package managers in the average JavaScript project, and I don't know what they are. So this is a universal problem. I think it's just particularly poignant when we're looking at Haskell because so little of the vocabulary is shared with so much other of the development ecosystem. But we're motivated, right? Like as a person who's worked with Haskell for about 10 years now, I'm motivated. I want people to understand. I want to know how to teach them. And I have failed at this spectacularly. I have done so many terrible things, and so I'm here to try to help you all avoid some of the pitfalls that I have made. So what's important when we want to teach? The most important thing when we want to teach is to empathize. When we're sitting down to teach somebody something, their motivations for learning are not our motivations for teaching them. And so we have to understand why they're giving us their time. Because they are. Their time, every person's time is a gift. And if they're giving it to you for some reason, it's important to reach out and understand what that reason is and then speak to it. Make sure that you're tying back everything that you're saying to what those intrinsic motivations are, to why somebody chooses to give you that time. And look for external motivations as well, because oftentimes it's a combination of internal and external motivations that are going to drive somebody to learn something. And then finally, be transparent. Don't try to act like this is purely for the good of the world, that you're putting that out there, right? Like I tell people, I teach Haskell because I like using it. And it's too hard to find jobs where I can use it because not enough people know it. So I'm going to solve that problem by trying to teach it. And whatever your motives for using technology, be open about them. And be open to understanding what other people's motives are for learning. And don't try to go too fast. It's very easy to fall into one or two traps when we're trying to teach something. One is, we get excited, right? Like, don't you love that feeling when something finally clicks for somebody, and you just see those eyes widen, and you can just, you know that they finally understand something, and that's just a thrill to have been able to give that to somebody, and so you want to do more of it. And the other side of it too is, isn't it great to feel smart? Doesn't it feel wonderful when somebody's a little confused to say, oh, you're confused about this thing, about haha, I know like 10 things down this way that are even more confusing. Because we like feeling smart, right? And it's kind of a jerk move and you don't want to do that, but it's always there, like in the back of your head. So both of those temptations we have to kind of suppress. And we have to make sure that we're taking things at a speed that are going to give people the opportunity to really internalize what they've learned and try to put it into practice and to push to their boundaries and sort of fail a little bit before we introduce the next concept. The next thing, and this is something that I learned about pretty recently, is this idea of something called SWOT. Whenever you're talking to somebody about a concept, think about what they're going to accomplish when you're talking to them, right? So SWOT, students will be able to. Comes from sort of the education space, how we go about teaching people, and phenomenally useful when we're dealing with individuals. Because if we think way back to earlier in this presentation, I said start with a bug, right? And this is a great way to think about SWOT. Start with the bug. Students will be able to fix this bug. And then just think about, what do they need to do? You're building a graph, a knowledge graph for what they need to be able to do to accomplish this task. So I'm working on a book right now to teach people Haskell. And the chapter that I finished most recently was on dealing with JSON data, serializing and deserializing it. And one of the exercises that I went through was building this knowledge graph. So students will be able to deserialize a JSON document. Well, what do they need to do that? They need to understand what JSON is, and they need to understand the ASON library. Well, if they're going to understand the ASON library, they need to understand libraries in general, and they're going to need to know about monoids and applicatives. And if they're going to know about applicatives, they need to know about functors, and for monoids and functors, they're going to need to know about type classes. But I just said a lot of words there, and I see a bunch of people squinting. Because if you think back several slides, what did we say one of the key failings of people trying to learn things is? Anybody? Yeah, exactly. So depth first search fails, but SWOT tells us to build a depth first knowledge tree. How do we rectify those things? With lies, damn lies, and metaphors. So one thing that I found people say is that teaching is a series of decreasing lies. And I don't like that, because we should never be lying to our students. I like to think of it like teaching is the process of incrementally building on more detailed partial truths. So if you think about our graph here, what we really want to do is we want to focus at this top level. We want that to be in focus. We really want people to have an understanding of what they're trying to accomplish. And every time we take a step down here, we're just going to get a little bit more handling. We don't lie, but we don't want to give people all of the detail. We get a little bit more abstract with every step. So if we look at this image here, we can sort of see visually what this practice is. So we start with our first version and keep it very blah, right? Like, people don't really need to know any of the details. They need to know that you go change this 1 to a 2 and that'll fix the bug, and we're successful. And as you go through this process, you want to bring sort of a core idea into focus, but you want to leave the background still pretty blurry. You know, you want to keep people focused on the one thing they're really trying to learn without lying about anything that's in the background, but without making people spend too much time thinking about it. And then what you're going to see is those items at the bottom of that knowledge graph tend to come up many, many times. And so each time you pick a new idea that you want somebody to be able to accomplish, they're going to run across that same set of things that tend to be those fundamental principles that are often very important but very hard to pick up on. And each time you just give them a little bit more detail until over the series of many weeks or months, they start to have a very clear picture of the context surrounding the ideas that they're trying to learn. Code reviews are a great way to do this because when you're reviewing with somebody, when you pair with somebody and say, hey, look at this code, you as the driver of the review have the opportunity to hand wave and tell people what they do and don't need to pay attention to. And so this gives you an idea where you can gauge where somebody's at and help them focus on the stuff that they need to know and help tell people when they don't need to think too hard about something that they don't need to know yet or is going to be overwhelming. So during a code review, students will be able to explain a specific piece of the code or find a specific bug in the code, make a small change, or explain part of the code to another teammate. And the further you're getting away from what they need to be able to do to accomplish that immediate task, the more and more you can hand wave over the details that are going to cause them problems. So while you're doing the code review, while you're explaining things, while you're going through the step first, you need to keep vocabulary in mind. Vocabulary is critical to teaching because people have to understand the words that you're using to explain things to them. Seems pretty obvious, but somehow is a huge failing of many of the texts that I end up looking at. So one technique that I think is really useful is using vocabulary words outside of a teaching context. If I'm talking about trying to teach people monads, rather than just sitting down and only using the term monad when I'm trying to teach them about monads, I'm going to try to use the word when I encounter it naturally in some other situation. This part of the code is monadic because of this. Give people exposure, give them many, many contexts where they can see a word being used in action so they can get a more holistic understanding of what it means. And they have many opportunities to sort of hang their hat on one particular piece of context. Another really important technique when you're talking about vocabulary is asking people to define vocabulary terms for you over and over again, because you're going to understand the evolution of how people are grokking a concept by how well they can define the terms that are being used to explain it. And look out for things that they explain just kind of weird, because a pattern that you're going to see is you'll ask somebody to explain something, and they'll explain it in a way that is not technically wrong, but it sounds off. You think, why would they explain that in that way? And that's often an indicator that they don't quite understand something, and that's a good opportunity to go back and try to sort of decrease the amount of partial truth that is their understanding of that particular concept or idea. And you want to avoid the burrito problem. And so when I'm dealing with teaching people Haskell, what I try to do is I try to avoid using words as much as possible to explain concepts. I try to give people a word for a concept and then explain the concept with as few words as possible, so I like to use code. So when you're trying to explain words, you end up, you get circular vocabulary problems and all that. But if you can just get somebody to bring up a rebel and you say, you know what, I know you don't understand monads. I'm going to show you what a monad is, because we're going to look at the type signature of bind, and we're going to look at the type signature of a couple of monadic functions. And you just get people to rebuild these concepts piecemeal. And as they're rebuilding them, rather than coming up with a bunch of wacky analogies and things that aren't quite right, they're going to get a real fixed understanding of what these concepts are that they're trying to learn. So finally, you've taught somebody some Haskell or some whatever language you're wanting to teach them. But that's not the end of it, right? Because we can't just learn a thing and then teach it and that's it, it's going to retire. We're in an industry where learning is continual and growth is continual. And, you know, we've all been the person on the team that had looked at something, we didn't like it, or we failed to learn it, and we push back, we treat something as adversarial. We've all run across an explanation and we didn't quite get all the words in it. And it's important to realize that this process of learning is really the process of teaching ourselves. And all of these concepts, everything that we've talked about, can be applied to easing the burden of learning new concepts for ourselves. So think about school lots, set a goal for yourself, understand what you want to accomplish, and then focus on the most immediate thing, the most immediate knowledge that you need to accomplish that. Make sure that you set a comfortable pace so that you don't burn yourself out. Spend the time to understand the vocabulary that's being used in your domain, and don't burrito yourself, right? Like don't make analogies in your head to avoid actually understanding the fundamental concepts. Make sure that you understand them for what they are. That's all I got. So, do you have any questions?